Hello students, welcome to today's class. Today we are on the second session of the chapter Universe, which is unit 12 of grade 10 Science and Technology. So in our previous class, we did a short revision of grade 9 very shortly, and we also studied about gravitational force briefly and its consequences as well. So we studied about a lot of things. However, we have not studied what exactly is universe, what was its origin and all. So today our class will be focusing on that. Okay. So proceeding to the class, I'd like you to show this image. I'd like to show you this image. What do you think is this? So here you can see time. It's 1922 and now. If you look over here, 100,000 light years. If you look at the next one, you will see 93 billion light years. You must be thinking that since 1922, the size of our universe was 100,000 light years and now its size is 93 billion light years. If you are thinking that, then you are wrong. This is not about the size of the universe. Rather, this shows about the known universe. In 1922, we knew very fewer, or let's say we knew very less things about universe, but at the present situation, we know a lot about the universe. Okay, or let's term it as we think we know this. We do not exactly know, but we think we know this. So this is simply the comparison of what we knew and what we know. So it just shows how curious we are. Okay, so let's look at this image. Although it has been focused, if you look at here, you might think that the largest thing in this whole universe is our solar system, but that is not correct because this diagram is not up to scale. This is simply an illustration. So if you look at this diagram, if you look at this figure, you will see lots and lots of things here. You are seeing lots of celestial bodies and you will see some galaxies, our solar system, some other stars, some comets, asteroids. You will see a lot of things. And if you search yourself, you are just a very small part of this universe. You have to go find Earth, and somewhere around Earth, you are there. So, universe is quite vast. So this entire thing, whatever is here, whatever is existing, whatever matter is here, is all the combination is known as universe. So it has its own definition. So let's look what is universe. So according to Merriam-Webster dictionary, it says that universe is the whole body of things, and not just things, but the phenomena observed or postulated as well. So we have a saying, like if something good happens or if something, we get some signs from someone, we just say that it's the way of you, it's the way that universe tells us what to do. So basically universe is not just about the available matters or masses, it is also about the phenomena which we observe. So according to NASA, we also have similar definition. So NASA says that universe includes all of space and all the matter and energy that space contains. So basically universe is everything. So what are the major components of the universe exactly? We cannot just say galaxy, we cannot even say human beings, we cannot just say some stars or planets. Rather, there are some major components which are termed as the primary components of the universe. So the first one is ordinary or baryonic matter. So these ordinary matters are simply atoms which are composed of protons, neutrons and electrons. And these are the observable things in the universe as well. So only 5% of the entire universe is filled up with ordinary matter. Means we are still unable to visualize the other portion or other percentage of the universe. So 5% of the ordinary matter occupies the total of the universe. And second, it's dark matter. So what is exactly is dark matter? We term dark matter simply as a mysterious form of matter which does not emit, absorb or reflect light, and it is very undetectable through direct observation. So this so-called dark matter, it occupies 27% of the entire universe. And you can see 5% among the three primary components of the universe. One is ordinary, which let's say it is the observable part of the universe, which is just 5%. Another is dark matter, which is 27%. So the third one is possibly the most occupying component, which is known as dark energy. So it is the hypothetical form of energy. What one thing we know about universe is, although we will study it in detail, one thing we know about universe is it is expanding. So they do not actually know why the universe is expanding, but we know that universe is expanding. So there is this they added a hypothetical term, let's say an hypothetical form of energy, which is known as dark energy, which is considered to be the cause due to which the universe is accelerating, or let's say it is moving at a certain velocity far away from each other. The celestial bodies in the universe, they are moving far away from each other. So this energy, it occupies, this hypothetical form of energy, it occupies 68% of the total universe. So among the three primary components, the observable universe seems to be the least one. Okay, so now we have some basic concept about universe. We know what are its components and what universe contains what things. We know all of that. Okay, so you must be thinking, how did it all start? Okay, we are studying lots and lots of things. So how the universe exactly began, or let's say how was it formed? What was the origin of the universe? Okay, let's be honest about this. Basically, nobody was there. The present human beings, let's say, who are alive right now, nobody was there during the origin of the, let's say, during the formation of the universe. So, we cannot exactly say that this happened and then I saw this and then this happened, in this way universe formed. Nobody can say that exactly. But various theories were proposed, and amongst them, the best one is acceptable. We will discuss some of the few proposed theories, and which is the acceptable one. We will look at it in more detail. Okay, some of the proposed theory for the origin of universe. First one is steady state theory. Second one is multiverse theory. Many of you might be excited with the term multiverse, because in many Hollywood movies you are looking at movies who create based on this concept, right? And another one is Big Bang theory. So among these three theories, proposed theories, there are lots other theories as well. We will not discuss every theories. We will just look at into this. And among these, Big Bang theory is the most acceptable one. We will look at the reasons as well. Why is it acceptable and all. Okay, first let's start with steady state theory. It was proposed in 1948, and it suggested something quite unusual, let's say. It said that the universe is eternal and it does not change on a large scale. How does it not change on a large scale? Let's see. According to this theory, it says that universe, as the universe expands, new matter is continuously created to maintain a constant density, leading to a steady, unaltered appearance over time. So, what does this mean? Okay, first we know about the term density. It is simply mass per unit volume, right? So, if something is dense, we know that the molecules is packed in that matter, the molecules are closer to each other. If we say that it is less dense, right, we understand that the molecules are far away from each other. Okay, so now with this concept, let's again look at this theory. When the universe is expanding, one common thing that we can guess is the universe must be becoming less denser. Why? Since it is expanding, the stars, let's say the galaxies, the planets, the stones, asteroids, comets, whatever there is in the universe, they are moving away from each other, meaning it should be less dense. But according to steady state theory, it suggests that whenever the universe is expanding, new matters form and they do not allow it to become less dense. It keeps the density constant, because as the expansion is happening, new matters are also being added in the universe. So it did not make much sense, because according to his theory, let's look at the visualization of here. See, if you look at this steady state model, here you can see the density is very constant, right? Although it is expanding, its size is increasing, but let's say the density, it is still the same dense, because it suggests that whenever it is expanding, new matters are being added here, which does not allow its density to change, but rather it allows it to stay steady. That is why it was named as steady state model. Whereas if we compare this with the Big Bang model, although we'll study about this later, Big Bang theory. So this Big Bang model suggested that whenever universe expands, density also becomes thin. Okay, so that was about steady state model, which was not accepted later on, because rather than steady state model, Big Bang theory made more sense. So another popular theory which was proposed by many scientists with their own laws is multiverse theory. This term multiverse, we are using the term universe, and here you see multiverse. So obviously you might be guessing what this word means. Okay, so basically this theory suggests or posits that our universe is just one of many in a vast multiverse, each with its own laws of physics and constants. So this means the universe that we are talking, like we said that everything, galaxy, every solar system, whatever is existing, we are supposing that as universe. But this multiverse theory, it suggests that there are lots and lots of multiverses, and the one we are studying is the only one that we know about, that is just one amongst many. And it arises from various theories in physics, including those related to cosmic inflation and string theory as well. So it was quite complicated, and it also has a visual representation, like simple illustration here. It suggests that there are lots and lots of other multiverses, and this is the universe, or let's say this is the only verse that we are talking about or we know about. And like this was somehow, let's say, it was not acceptable, but the problem, or let's say it was difficult to falsify as well. We could not say that this is false, we could not say that this is true, because we could not prove, scientists could not prove that multiverse exists, right? For that they had to do lots of study, they had to prove some other universe exists and all. Whereas for this there was no we could not contradict as well. Why? Because we cannot prove because we don't know what is out there, and we cannot say that there is no another universe, there is no multiverse and all. So we cannot exactly falsify this as well. So this theory is still there, but it is not much acceptable as Big Bang theory. So the most acceptable one is Big Bang theory. So what does this Big Bang theory suggest? We have heard a lot about this term, right? So whenever this term comes, Big Bang, lots of us assume that it might be explosion. So Big Bang is not about explosion, it is rather about the expansion. So this Big Bang theory suggests that approximately 13.8 billion years ago, the universe began as an extremely hot and dense point that expanded rapidly. So, this Big Bang theory talks about singularity. Singularity meaning a very hot, dense single point. So it suggests that the existing universe it started from singularity, which was 13.8 billion years ago. So at the initial point it was very hot, very dense, because lots of matter was constricted in single point. Okay, and it suggests that it expanded rapidly. And it also says that this expansion led to the cooling and formation of fundamental particles, atoms, stars, galaxies, and the large scale structure that we observe today. So, this theory is widely accepted by the astronomers and scientists as well. It was also named by singularity, where it says that all of it started from one single dot, or let's say one single dense and hot point, extremely dense and hot point. Okay, so here is, according to the Big Bang theory, here is a timeline as well about the history of universe. Okay, here are some important timelines have been mentioned in this chart. Firstly, when here you can see it started from a singular point. Okay, and if you look at its nature, you can see the universe is gradually expanding, and here at our current situation there seem to be some acceleration, right? Because you can see a curve here. But right here, if we look at this, at the very initial state, the expansion was not gradual, it was exponential. The expansion, it started from a single point and it exponentially started to expand, which was even in less than 1 microsecond, the inflation started. The expansion, the exponential expansion of this singularity point was known as inflation. This state is known as inflation. It was not a gradual expansion, rather it was a rapid expansion. After that, it started, the expansion gradually decreased and then it started to expand very, here you can see it started to expand in much lesser rate. So after 1 microsecond of this expansion, of this origin of the universe, let's say, after just 1 microsecond, first particles like neutrons, protons, and electrons were formed. And after 3 minutes, okay, so although we are talking about the origin of the universe and we might think that it took millions and billions of years, the thing we are just discussing is within split of seconds. We are talking about 3 minutes now. So after 3 minutes of this expansion of the Big Bang, let's say, so first nuclei was formed. Another important thing to remember here is after 3 minutes to 20 minutes of this Big Bang, lots of light elements like helium, hydrogen, and lithium were formed. Okay, so 3 to 20 minutes, lots of light elements, light nuclei started to form. Okay, then we can see another gradual change is after 380,000 years, the first atom was formed. Okay, before this, See, the universe is expanding and it was also cooling down. Okay, so before this, due to very high temperature, photon was unable to flow due to the presence of many free electrons. But after 380,000 years, first light was observed, and also let's say the first photon also started to freely walk. Because there were less free electrons, they started to combine, which was also known as recombination state. So here you can see first light. Okay, so first light meaning the in present situation we name it as cosmic microwave background radiation. Previously this light, this radiation was in the form of visible light at this state. And after 200 million years, first stars were formed, whereas after 400 million years, galaxies, we talked about galaxies and dark matter, galaxies started to form in dark matters as well. And after 10 billion years, the concept about dark energy was also assumed to have formed. And after almost 13.8 billion years after the Big Bang, which is today, we are observing about this whole universe, we are studying about this universe. Okay, with a short history of the universe, let's try to solve some questions. Choose the correct alternative for the following questions. Which theory proposes the universe is always expanding while maintaining a constant average density? Okay, option A, Big Bang theory. When we talked about Big Bang theory, we talked that universe is expanding, but the density is also becoming, let's say, the density of universe is also getting thinner. So it is maintaining constant density, average density in this question. So Big Bang theory is not the correct answer. Another is oscillating universe theory. We did not study about this, but oscillating universe theory means, according to this theory, the universe has lots of cycles of contracting and expanding. So this is again wrong, because we are talking about always expanding. Another is steady state theory. Now this might be correct, because about steady state theory we studied that this theory suggests that the universe is expanding but the density is staying constant. And option D, multiverse theory, it talks about other possible existing universes as well. So the correct answer is option C, steady state theory. Let's go to another question. It is like a follow-up question of the previous one. According to the steady state theory, how does the universe maintain a constant density despite its expansion? Okay, so in our previous question we said that steady state theory, it suggests that the universe is expanding but the density is the average density is constant. So how does it maintain this average density? Let's see. Option A, galaxies move closer together, maintaining density. Option B, the universe's expansion rate slows down over time. Option C, dark energy counteracts the effects of expansion. Option D, matter is continuously created to fill the gaps left by expansion. So, according to what we studied about steady state theory, the correct option is option D. Matter is continuously created to fill the gaps left by expansion. So this was according to steady state theory. But we are now focusing on Big Bang theory, which is the most and widely accepted theory by scientists and astronomers as well. So why are we why are we accepting this theory? Let's look here. Because we have some evidence of this Big Bang theory. Lots of other theories, they did not have enough evidence for us to accept it, but this Big Bang theory had some of the major evidences that we will talk about today. First one is cosmic microwave background radiation. Second is abundance of light elements. And third one is Hubbles law. About Hubbles law, we'll again study it in detail because it talks about the expansion of universe. So first, let's look at this cosmic microwave background radiation. Okay, so earlier when we looked at the history of the universe, we said that the after 380,000 years after Big Bang, what happened? First photon was formed, right? So at that time there was visible light, and gradually what happened? That visible light came to the range of microwave range. Okay, so when it came to this state, we named it as cosmic microwave background radiation, which is still visible and which is the considered to be the remains of Big Bang. So what exactly is cosmic microwave background radiation? It is a faint glow of electromagnetic radiation that fills the universe and is a critical piece of evidence supporting the Big Bang theory. It is also considered the afterglow of the Big Bang, because 380 years later, first light was formed. Let's say first photon was formed. Before that, photon was unable to form due to high temperature and the abundance of free electrons. Okay, so during that time, whatever we call the visible light, right now we call it cosmic microwave radiation. So it can be seen in this diagram. Here you can see different colors. Some of them are green, red, yellow and blue. Well, these colors, they do not represent the colors of the radiations. Rather, it shows the temperature difference on these areas. So, red is for very high temperature, whereas blue is for cooler ones. So, that is one very major evidence about the Big Bang theory. Second one is abundance of light elements. Now, if you remember correctly, after 3 minutes of Big Bang, what happened? First nuclei started to form. So within 3 to 20 minutes of the formation of this universe after Big Bang, many light elements started to form. So if we look at the data, we will see that the relative quantities of light elements such as hydrogen, helium, lithium in the universe is pretty high. And the observed abundance of these elements strongly support the Big Bang nucleosynthesis model as well. Now, if you look at this graph, you will be able to see in the x-axis there is atomic number, in the y-axis you can see the relative abundance, where you can see hydrogen and heliums, they are pretty high, their abundance is pretty higher than the other elements. So, this is another evidence of Big Bang theory. And another important one was about the expansion of universe. So, which was done by Edwin Hubble. As you can see in this image, he is a scientist, Edwin Hubble, who did many studies regarding astronomy as well. So, his study of distant galaxies revealed that galaxies were not static but were in fact moving away from us. Okay, how did he did this study? Firstly, before doing this study, previously he did another study about the Cepheid variable stars which were present in Andromeda. So I told you that Andromeda is our neighborhood galaxy. But before before his study, Andromeda was assumed to be nebula. And later on, when he continued this study, he came to know that those stars were very, very far away from our home galaxy. So later on, it was found that it was of some other galaxy. So from that, we knew that our galaxy was not the entire universe. There are some other galaxies in this universe as well. Whereas later on, when he studied about the motion of various galaxies, when he looked at its distance and velocities, he was able to observe the redshift in the light from these galaxies. And he found that the farther a galaxy was, the faster it was receding from Earth. So he came up with a relation of velocity and distance of the galaxies as well. So before proceeding further, let's be clear about these two words, redshift and blueshift. If any object is moving away from the observer, the light from that object will shift towards the red one. The frequency is shifted to the red. We call this as red shift. But if any object is coming closer to the observer, then the frequency of this object is shifted towards the blue one, and we call it as blue shifted. So if we observe red shift, then we should know that object is moving far away from us. This is what Edwin Hubble did. He observed this by using this telescope, which is a 100-inch Hooker telescope, which is situated at Mount Wilson Observatory. He used this telescope to calculate the velocities of various galaxies as well. After his study, while he did this study, he not only studied about the motion, he also calculated the velocities along with the distances as well, and a graph can be seen here. On the x-axis, you can see distance. On the y-axis, you can see velocity. This is the velocity versus distance time graph of what? Of the galaxies. And here, and almost every dots in this graph represents different galaxies present in our universe. So here we can see when the distance, let's say we are talking about this from the viewpoint referring or relative to Earth. Okay, so the galaxy, if you look at the distance, if the distance between Earth, we observer, and the galaxy is increasing, we can also see their velocity is also increasing. It means that the velocity is directly proportional to the distance. So with this, Hubble's law, it stated that the velocity at which a galaxy is receding from us is directly proportional to its distance from Earth. And he also gave a mathematical expression for this law, which is known as Hubble's law, V equals to h naught times d, where v is the recession velocity of the galaxy, h naught is the Hubble's constant, and d is the distance of the galaxy from Earth. So Hubble's constant, it has a value 73 km per second per megaparsec. So we will again study about this, like the value of Hubble's constant is 73 km per second per megaparsec. What does it mean? So if you are asked this question, you should be able to be clear that it means if two objects, or let's say if a galaxy is at a distance of 1 megaparsec, okay, let's say let's talk about one is Milky Way galaxy and another one is Andromeda galaxy. If these two galaxies are at a distance of 1 megaparsec, we are just assuming, okay, so if they are at a distance of 1 megaparsec, then they will be moving away from each other with a velocity of 73 km per second. So this is what this is its meaning. We can say that if two galaxies are at a distance of 1 megaparsec, as I mentioned, they are separating away from each other with a velocity of 73 km per second. Okay, so in our today's class, we focused on the origin of the universe, some of the proposed theories about the origin of the universe, and we also focused on the expansion of the universe, which was proved by Hubble's law. Edwin Hubble not only discovered that the galaxies are moving and not static, he also calculated, or let's say he showed the relation of the velocity and the distance of certain galaxies, of many galaxies, and with that it was directly proportional. They had a directly proportional relation. He also gave a mathematical expression for that, and he also used Hubble's constant, which has a value of 73 km per second per megaparsec. So with this, let's try to solve some questions and choose the correct alternatives from the below questions. Okay, first one is the redshift of galaxies as observed by Hubble indicates that the universe, option A, the universe is contracting and galaxies are moving towards each other. Option B, the universe is expanding and galaxies are moving away from each other. Option C, the galaxies are stationary and redshift is caused by other factors. And option D, galaxies are moving faster in the past. Now let's see. In our class, when we studied about redshift, so when some object is moving away from the observer, it seems that object seems to be looking like a red. It looks like it's emitting a red light. Why? Because the light from that object shifts towards, its frequency shifts towards the red one. So with that information, our correct answer is option B. The universe is expanding and galaxies are moving away from each other. Let's look at our next question. What is the primary observational evidence that led to the formation of Big Bang theory? I think by looking at the options, you are already able to tell the correct answer. The correct answer of this question is obviously option C, the cosmic microwave background radiation. Okay, so before ending this class, I would like to assign you some tasks. Let's look at this diagram. Let's look at this image. You have already seen this in our earlier phase, right? So our main question for your next class, I would like to request you do this task. The Big Bang theory suggests that the universe began from an incredibly small point. What does this tell you about the potential future of the universe? Could it expand forever or might it eventually collapse? For this, I would like you to also do one activity and show it to your teacher. Create a visual timeline of the universe from the Big Bang to the present day. Imagine the future. Will the universe continue to expand or will it contract? Illustrate or describe your thoughts. Do this, try to solve these questions on your own with your own perception and show it to your teacher. In our next class, we'll be studying about the future of the universe. Study well and we'll see you in next class. Thank you.